connect back, with interference, interference is the meeting of two coherent waves moving in the same medium with the same speed. So this is like a synchronous motion, like when you see the soldiers march past and when you see the the squadron fly in a march past style. Or I gave you a very good example. If you have a taste of watching those acrobats, especially the Chinese acrobat, they're just like many students and they move together, their hands and everything. They are exactly in synchrony with each other. This is coherence. Now, coherence is actually a type of synchrony. So when two people have a chance of practicing chorus singing, this is a very good example of coherence. Coherence exists between identical waves. Coherence is the primary condition for interference. Our syllabus especially highlights it. Look, these are the two signals which are considered to be exactly in phase. And look at them, they have a constant phase difference. And what is this? They are exactly out of phase. What's the meaning of out of phase? Out of phase means that one signal has the crest and other signal has the trough. It is called exactly out of phase. Now, conditions of interference. The first condition is coherence, then same medium, same speed, meet at a point, which means superposition. I had explained superposition before also, that when you place your two hands on each other, this is the best example of superposition. So the waves should be meeting like this. This is called coherence. I think we have mentioned this in our last class. Coherence is basically, this is a case here. Look at this example. These two signals cannot superimpose. So interference cannot occur. Let's take it as our first question. Why these two signals cannot interfere? Yes, can you hear me?
Oh, sorry, I was muted. Yes,
No.
because they aren't coherent and they aren't in phase.
They are not exactly the same. So interference exists only in this case. So I put my second concept for today. My second concept, there are two types of interference. This is very similar to our social life when we interact with people. So we find that people and we also interfere in each other work. This is how we work. This is how the social fabric works. But there are two types of interference. One is constructive and second is destructive. Similarly, waves do the same. They are very social like us. They also interfere constructively. This will increase their size, and they also interfere destructively and they decrease their or even zero their size. This is the second concept for today. So you have to copy this.
Okay, got it.
Good. Now, waves meet exactly in phase. This is called constructive interference. When three people are playing a music, like in a concert, you will find this feature constructive. And when waves meet exactly out of phase, it is the destructive interference. So we made our second concept. Look at this diagram. Look at this diagram. The two waves meet and they get bigger. There are two waves, they meet and they get bigger. This is called constructive interference. The amplitude increases. When they move constructively, when they meet constructively, they form an antinode. What is an antinode? Antinode is a point of maximum amplitude. So let's make our third concept for today. When waves meet constructively, they form an antinode. Amplitude increases. It is not necessary that amplitude always double. Maybe one is 2A, second is A, so the result is 3A, but still it is constructive interference. Now look at this. One has a crest, one has a crest, one has a trough. It is called exactly out of phase. When such waves meet, they cancel out each other, and this gives you a node. So my third concept for today, destructive interference generates a node. Destructive interference generates a node. Now, the same concept, it is not necessary that the two waves always cancel out each other. This is a relatively smaller signal, and this is a relatively bigger signal. They are out of phase. One is up, one is down. They will minus, but the answer won't be zero. It is not a node. So remember this concept that when waves meet at a point, when waves meet at a point, they can constructively or destructively behave.
The overlapping of wave pulses causes the displacement of the string and is the sum of the displacements due to each separate wave. If we want to determine the shape of this string at a given point in time, for example, at the moment when two identical waves are completely overlapping, then at each point we add up the displacements due to each of the separate waves. So, at the moment when the two waves have completely overlapped, the resulting wave will be twice the height of an individual wave. If we invert one of the waves, then at the moment when they completely overlap, the displacement of the string will be equal to 0.
So I hope you understand this concept. There are two types of sources in our course. One is called a point source. Second is called an extended source. So point source is very sharp. Look at these are 2 point sources. These are 2 point sources, S1 and S2. They are generating waves, and the waves are interfering with each other. Some points they are constructively and some points they are destructively. How we identify constructive or destructive interference? The logic is simple. Remember that when crest meet a crest or trough meet a trough, it will be constructive. When a crest and a trough, dotted line and continuous line meet, it will be a destructive interference. Now look at this position and look at this position. First, you look this position. When you look this one, P and R are node. Can you tell me on P and R, look at the diagram, that P and R, are they constructive or destructive?
Let me see. So P is resting on a trough, and
Hmm.
R is resting on a
No, no. First, I discuss P only. P is the intersection of two
yeah.
lines.
Oh, sorry, yeah. So P is on a trough on the left one, and on the right, P is on a uh
Crest.
crest, which means they will destructively interfere, therefore causing zero displacement.
And same rule will apply for R also. When you talk about Q, now talk about Q.
So in Q, both the troughs superimpose, which therefore causing constructive interference.
Good. So we got the point. Trough plus crest, exactly out of phase destructive interference, and this can generate a node. Node means zero intensity. So you have to copy this summary.